Hello, today I'll be presenting about the third lab of Physics 2 course in Georgia Tech, the magnetic fields of bar magnets. So the purpose of the lab experiment was to observe and better understand the magnetic field through a visual representation and to visually observe the relationship between the distance and magnetic field. And lastly, to use the distance dependence of magnetic fields of Biot-Savart law to find the magnetic moment of a bar magnet. We have concluded the data of three parts: the magnetic dipole moment, measured off-axis magnetic field, and simulated off-axis magnetic field. Among the fundamentals that we used in this laboratory, the first formula was about the Biot-Savart law, which is dealing about the magnetic field for uh, depending on the shape or the area or the location. So the first formula is about the magnetic field for a divided section, and the second one is about the dipole moment and magnetic field of the loop, and the last one is about the magnetic dipole moment. The other formula that we use are the magnitude of magnetic field of magnetic dipole moment on the perpendicular axis, and the magnitude of the magnetic field due to a bar magnet, formula of magnetic field of magnetic dipole. So in the experiment, we have set the system as a bar magnet and the surrounding as everything else. And the initial conditions that we got was the bar magnet and a magnetometer on the phone. We have located the phone and slide it perpendicularly to the ruler with the magnet in order to see which position of the phone relative to the magnet has the strongest magnetic field. On the axis, distance from the bar magnet to the magnetometer was measured by using the ruler for several different magnet field values. These values in Excel data were linearized by taking the natural log on each side and portrayed in the graph, which is shown in the right end of the Excel file. Lastly, the off-axis magnetic field of the bar magnet was calculated. So we have observed that when the magnetometer was far away from the magnet, it measured almost zero magnetic field in the x-axis. And as the magnetometer moves closer to the magnet, the measured x component of the magnetic field increases. So here's a glow script model that I've coded. And I've set the observation axis and perpendicular axis as a vector by using the x and y and z component of putting the distance in it. And I've set the distance as 0.2 and the B scale as 1000. This is a code that is useful for displaying the arrows by displaying the arrows of magnetic field by locations, and it's a result of the direction and the magnitude of magnetic field according to the location and direction. Moving on to discussion, the sources of error that is possible in this experiment would be the location and direction on the phone might have a potential error due to the reading of the magnetometer might not match the Earth magnetic field in 100% scale, and also the surface might not have been flat. And lastly, the measurement error may just done by us because we have done the measurement by ourselves, not using the accurate calculated data. So the first question of this discussion starts by, what if you hadn't oriented your experiment to compensate for magnetic north and had instead laid out your meter stick at some intermediate angle with respect to Earth magnetic field? What would have changed? I think measured magnetic field would be different due to the accounting for the other direction than north, and due to the intermediate angle created, the x and y component would have changed. However, as the direction only changed, the z component would remain the same. For the second question, is about the what if you were to stick two identical magnets together end to end and run the experiment again. How would you expect your measurement to differ? The magnitude of the magnetic field would increase due to combined magnetic field of two magnets. And due to the law of superposition, I would expect the magnitude of magnetic field would be doubled approximately. And the measured distance for each magnet would decrease because the magnetic field has increased. Thank you.